Hello and welcome to CHEMS. Today we're joined by Dr. Lianne Lefsrud, the Risk Innovation and Sustainability Chair at the University of Alberta and CEO of Insight Risk Systems. Dr. Lianne's work bridges research, innovation, and industry, focusing on risk management, sustainability, and how AI and data can transform decision making in engineering systems. Thank you so much for joining us today, Dr. Lianne.
Yeah, thanks so much for having me, Cheryl. This is awesome.
Great. So, to begin with, can you tell us a little bit about yourself, your journey so far, and what led you to focus on risk, innovation, and sustainability?
Sure, absolutely. I have no degrees in chemical engineering, just to put that on the table first and foremost. What I do have is an undergraduate in civil environmental engineering and a master's in environmental engineering sociology. And what I did for my master's was I did a co-op undergrad and was really interested in how do we manage our waste and thinking about inherently safer design in even circular economy. What does that look like? So my master's research and why I did it between environmental engineering and sociology was I did research with the U.S. Army looking at chemical demilitarization of getting rid of chemical munitions from the Cold War. So they have these big stockpiles of chemical munitions, and it could be VX or sarin or mustard gas in rockets or tunners. And the problem with a lot of these chemical munitions is that as the chemical weapon itself, or the active ingredient, the toxic chemicals degrade, they become caustic, and they were starting to corrode the casings of the munitions themselves. So they wanted to figure out a way of, or what the best way of destroying these munitions, if they should ship them, if they should burn them, if they should crush them on site, some central location. So my research was actually working with the U.S. Army and the local community to determine the local community's risk perceptions about the facility, about the different methods of destruction of these munitions. And again, I was doing effectively inherently safer design before inherently safer design was a thing. So I thought it was really very cool research. By the end, I didn't want to have much to do with the U.S. Army. So then I went and worked for CN Rail for 7 years. I was cleaning up derailment sites. I worked in engineering, looking at rock falls, risk management associated with maintenance of track, maintenance of equipment, locomotives. I worked in transportation for a while. And what struck me was railroads, and a lot of companies would like this, manage risk on a trial and error basis. So CN, for example, set aside $300 million per year for derailments because they were considered to be inevitable. And then this money was set aside to be able to clean up the resulting damage. And I thought that seemed really wasteful and kind of reactive, when I thought, why would we not want to be proactive and prevent a derailment from occurring rather than having to set aside $300 million, which is a lot of money to clean up it after the fact. So then I worked for regulator for a while. I worked for APEGA, and I was the assistant director of professional practice. So I wrote a bunch of practice standards, practice reviews, environment committee, discipline. And it struck me that a lot of regulations, an act of faith. So we put rules in place. You assume that companies and individuals, professional engineers and geoscientists are following the rules. But unless you audit them, you really don't have an idea of how closely they're following those rules. And even if you audit it, it's hard to find things. So then I did a PhD in business strategy and then a postdoc at University of Michigan in the Urban Institute for Sustainability, because I was really interested in kind of where engineering meets business, meets society, and how do we make those connections? And if we can better understand how organizations make decisions about risk, about sustainability, and about innovation, then we can help them make better decisions. So I was at University of Michigan, and then I was recruited back here to University of Alberta. And I've been here for just a little over 10 years. And I've been Risk Innovation Sustainability Chair for the last 2.5 years. And it's an interesting intersection. And you're right, Cheryl, it's a bit odd. But if companies think broadly, and risk management is a really nice framework for doing that, because the finance people, you'll see MBA types, you'll see insurers really think about enterprise risk management. So they're thinking about kind of probabilities and consequences of both positive and negative on kind of the organizational level. And then I focus in on the operational risk management. So that's usually process safety, occupational health and safety. It's related to maintenance and reliability. It's also related to innovation and the whole technology development space. And that's a really interesting space to be in. And since I've been doing this, and my research is this is at that intersection. And since I've been doing this, I do research with railroads, looking at how do we improve their we just did some stuff with CPKC, the Canadian Pacific Kansas City, on field testing, basically machine vision, computer vision for inspecting trains as they go by in an automatic train inspection portal. So I do work with railroads. I do railroad like derailments for if we have toxic releases of, like, say, ammonia or chlorine. How do we predict where the plume would go, and how we should protect people or prevent a release like that from occurring. I do work on hydrogen, so hydrogen various release scenarios for different use cases, hydrogen refueling stations, on the basis of the work that we did with Alberta Innovates. Now we have Strathcona County, who's actually approved the development and the building of a hydrogen refueling station based on our work. I do work with, circular economy, getting rid of microplastics in the environment, and how do we think about the innovation cycle and circular economy differently. So it's a really great space that I'm in, like I said, with risk, sustainability and innovation, and then how do we help companies better understand those risks, and then prevent them from occurring, right? And support innovation and sustainability at the same time. So I love what I do. I love it. So it's been kind of a weird journey, Cheryl, but I've kind of built my own playground, right?
Yeah, I mean, you worked across academia, industry, and now like entrepreneurship as well through Insight Risk Systems. So, like, what inspired you to start this venture? Like, and what problem are you trying to solve through this venture? Could you tell us a little more
Well,
about it?
yeah, absolutely. So, together with a colleague of mine, Dr. Fresh Satari, we've developed a number of algorithms. So, part of what we do with companies is we actually look at their incident data. So, when they have a process safety or an occupational health and safety data or incident, then they create an incident inspection, and then they'll have, and it could be an actual incident, it could be a near miss, and then we have other data that looks at their inspections, their audits, their maintenance records. And what we've done is develop a number of algorithms for natural language processing and data visualization that we've now patented to be able to say, what are they missing? What are the missing leading indicators? And how can you better do inspections so that you're catching those latent factors, those latent deficiencies, and to be able to prevent that incident from occurring. So we worked with a bunch of industrial construction companies, a bunch of mining companies, energy companies. And what we realized was these algorithms, when companies start to ask you to do it for their data, it stops being research and it starts being consulting, right? And so when we developed our algorithms and got the patents, the University of Alberta Technology Commercialization Office said, I said, well, do we license this? Like, how does this work? What do we do next with the patent? And they said, well, actually, the most successful way of commercializing a patent is if the inventors create a startup. So I'm like, oh, so we should start a company? They're like, yeah, you should totally start a company. I'm like, so the university wants us to start a company? And they're like, yeah, we want you to start a company. So Fresh and I started this company, Insight Risk Systems. We incorporated last December, so we're not even a year old yet. And then now we're doing this data analytics, and we're looking at how do we then take our algorithms and embed it into software as a service. So that's what we're working on right now. So that's why we started our company. It's because there's this demand for our data analytics and for using machine learning and natural language processing to provide those insights. So how do you take thousands of incident reports or tens of thousands or hundreds of thousands of different data points? How do you find those patterns, those missing leading indicators to be able to better see the latent causes, and then help companies address those, track those, and then as a result, prevent incidents. So that's what we're doing. we're having super fun with it. We've had a surprisingly successful first year, which is great. And we're being approached now not just by Canadian companies in petrochemical, mining, but also like international companies. So a number of Peruvian gold mining companies now want us to work with them. So it's kind of cool, right, to then say, okay, now how do we take our this cool intersection of process safety, data analytics, understanding kind of the human and organizational factors, and then provide this as a service or software as a service more broadly. So this is the ability not just to prevent one derailment or one incident, but has the ability to transform whole industries, right? So if they can think or see differently or understand the causes of incidents, then they're much less likely that they'll be able to prevent them, right? So that's really, it's thinking about scalability. And that's what Insight Risk Systems allows us to do is change the systems, and in doing so, change the industry. So it's quite exciting to think about it, actually, like super exciting.
It's very interesting. I mean, your work uses like advanced data analytics and AI. So, like, how is AI transforming the way we understand and manage safety in engineering today? And how important is it for the current engineers, especially the new graduates, to learn AI? Like, not just focus on just the engineering studies, but to go one step further and learn AI and data analytics.
Yeah. So there's a bunch of different tools that companies are using right now. A lot of the large language models, the LLMs like ChatGPT, they're really nervous about using. Why? Because they don't want to send their very private, sensitive corporate data up into a cloud for processing. Okay. So some companies are developing their own LLMs, but they tend to be the minority of companies. Some companies might use an LLM to generate like a job hazard assessment or a start work check for a certain activity. So that's kind of sort of what they're using it now in a very limited manner. They're not really doing data analytics, not yet. And why? It's because they don't necessarily know how to do the data analytics in-house. And the people who might know the data analytics are not necessarily the same people who would understand the process safety or the human and organizational factors, right? So they don't have that same confluence of subject matter expertise that's required to do that. But machine learning is a bunch of different things, right? And even simple natural language processing, NLP, the kinds of insights that you can find when you analyze textual data, right? And if you can have an understanding of a decent understanding of the statistics, the different ways of visualizing, then what it does is it provides those insights for companies that can be absolutely transformative. And I see increasingly, whether or not it's in chemical engineering data analytics or mechanical or civil, that's really where those transformative insights are coming from. Like, how do we take the biggest of big data sets and then distill it down into very actionable recommendations for companies to improve whether or not it's their maintenance programs because they have better oil testing and can understand the cycle of and improve rather than just an hour-based, we have to change the oil and do these overhaul on these engines, every, 2,500 hours. Can you do it sooner? Should you do it and avoid engine damage? Could you do it later and minimize the expense? So it's really, and chemical engineers are already doing this already, especially computer process control optimization, right? That's what this is. And AI, machine learning, natural language processing allows us to do optimization on a big scale, right? Using different kinds of data, right? So you're not just optimizing on sensor data in a refinery, right? Pressure and temperature and flow data. You can think about organizationally, what is effectively the system, right? And the pressure and the temperature and the flow of information, of knowledge, of decision making, right? And you can think about a process flow diagram looks a lot like a decision tree, right? So when you put them side by side, process flow diagram, decision tree, it's like, oh, it's exactly the same sort of thing. Like a PLC, like the logic controller is effectively a decision tree. And that's what AI machine learning does, is it takes different sources of data, like I said, textual data or maintenance data or even HR data, and puts it into like effectively a PLC and a decision support system, right? So we're kind of doing like computer process control optimization on a bigger system using more data sources. So that's kind of a nice way for a chemical engineering, like a CPC person to kind of think about it, right?
Oh, makes sense. I mean, your work through research, you've been in the industry, you're doing AI innovation. So, like, what advice would you give to the new engineers out there about, where they should focus and how they should put their foot, like, especially now with the economy and everything going on? Like, what advice would you give since you've seen all the different paths?
Yeah. So what I would suggest is engineering is a fantastic undergraduate degree. Why? Because it trains us to be super logical thinkers, to think in systems. People say, oh, systems thinking. What do you think engineers do? We design systems, we build systems, we optimize systems. We're the first and the ultimate systems thinkers, okay? But what I would argue is we can't only just think of a system as being the built system, right? Like it's not just, a P&ID diagram, right? And when I teach sustainable design, it's kind of a bit mind-blowing for my graduate engineers to think about, okay, your system isn't necessarily physically connected. It's not just the pipes and the vessels, right? You can also have the people and the decisions and the flow of money and the flow of information, right? So you have to kind of layer the people and the information flow and the money flow and all of these other flows, right? You can think about it as, nodes and links on top of a technical system. So my advice to engineers would be, don't really think about your technical system, think about it as a socio-technical system. So how do the people interact with a built environment in terms of how they design it, how they operate it, how they maintain it, how they might decommission it. And if you can think in those bigger systems perspectives, then you'll be well equipped to kind of understand how organizations operate, how they make decisions, how regulation happens. So that would be, kind of thinking bigger outside the kind of the physical or the technical system to kind of a socio-technical. That's my first piece of advice. My second piece of advice is, follow what you love, right? Like, what are you interested in? Like, what excites you? What fires you up? And it could be, what course did you take? Like, was it, reactions? Was it CPC? Was it, what was it that really excited you and got you motivated to do the assignments, to talk to the professor, to get a job in that area, and think really about and it could be the kind of the technical content, but it could also be like, what is it about characteristics of the work? Like, do you want to be an entrepreneur where you're your own boss? Great, love it. But there's a whole bunch of uncertainty. Would you rather work for a big company where you make good money and you have a secure career and a nice defined career path? Great. Okay, that could be really great too. However, recognize that, the concept of staying with one company for 30 or 40 years is becoming a rarity. Do you think you might want to work for government? You might want to work for a nonprofit. Do you want to go back and be a lawyer, get your law degree? I really think that that kind of not just the technical content of what fires you up, but also what are the characteristics of the work? What do you like best? Do you want to work in a team? Do you want to work independently? Do you want to work remote? Do you want to work in person? Do you want to travel? Do you want to never have to travel? Those are the kinds of questions that it's important to kind of ask yourself, right? And the answer could change over time, right? Like when you're young and a fresh engineer and you're like, yeah, give me all the travel. I want to see the world, right? But when you're got, a young baby at home or a spouse that you want to see more regularly, then you're like, no, I don't want to travel now. So what you need in your career can change over time too, right? And recognize that that's going to evolve, and that's okay. And you can change your mind, and that's okay too, right? So when you tell your mom, oh, I want to be, X, and then you say, well, I don't want to be X, and your mom's like, but I thought you would, and you say, no, you're allowed to change your mind, right? You're allowed to evolve, right? You're allowed to be interested in different things, and to follow that path, like follow your passion, right? There's so many interesting things that we can do, and so be fired up and excited by what you're doing, right? And how you want to make a difference in the world, how you want to show up. Super important.
Makes sense. I mean, so my last question would be like, if someone wants, like, you have been able to bridge the gap between, like, you have been working with research, innovation, and sustainability, all of which are quite important now and which, which will help us go forward. So, if someone wants to follow the same path, if someone is interested in all three and they want to combine all, like, what would be like an ideal roadmap? Like, obviously not a set ground of rules, but if they had to do something, like, how should they start and where should they start? What are the skills they need? And like so that they can start working on it, and like what would that career look like for them?
Yeah. First of all, it's important to be technically excellent at what you do. Okay. Like that's super important. And I see, MBAs, they can give a really great presentation, but they don't understand technically how something works. Okay. So it's important to understand like the thermodynamics of a system. And someone says, oh, I'm going to do this. It's like, thermodynamically, that's impossible. So yeah, no. Right. So it's important to understand exactly, like I said, what is your system? What are the dynamics and how can you understand or characterize the system? Okay. So that's important to understand, to be technically excellent at something. Okay. And it could be a big something. It doesn't have to be so specific as, a catalyst for direct air capture, of carbon dioxide out of the atmosphere. It could be surfactants. It could be polymers. It could be, a very much broader range of kind of technical expertise. Okay. So it's important to know what your technical expertise is. Okay. The second thing is find an industry that you really want to make a difference in. Okay. And it's best if what you love is also how you make a difference in the world and also how you get paid, right? It's kind of nice to be paid, okay? Like being paid is a thing. And the nice thing with grad school for engineering is grad students almost always in engineering are paid, okay? It's not a lot. You're not going to become rich, but you're going to be able to eat and have a roof over your head, okay? So you shouldn't do graduate studies unless you're paid, okay? And you should do graduate studies on a topic that you love with a professor that you really you're putting your faith in that person. Okay. And I was doing a workshop and I took two of my PhD students, and as we're driving back, I was talking about, in Germany I would be called a doctor mother, right? Because what do I do? I know you're making a face. It's like I'm not, making, what I'm doing is I'm making doctors, right? So I'm not just helping them, teaching them a class, but I'm also developing them as professionals in terms of how they think, how they approach a problem, the methods that they develop, how they analyze their data, how they present their data. Like I'm really developing a whole person as, a critical thinking, productive professional, right? So if you're going to do graduate studies, also make sure that this is a professor that you would want to be best friends with for forever, okay? Like, or someone that you admire and you think, oh, I'd want to have a career like them. But they should also be like a good person that you could work with, okay? Because there's no shortage of professors who take advantage or who can be, super demanding or even cruel, So it's important to be able to not only be excited about your research and in an industry you want, but also work with people who fire you up, because there's nothing more soul destroying than the perfect project, but a professor or a supervisor that just drains the joy out of it, like drains the joy. And then next thing you know, you're ruined, right? Because the thing that you love the most has been ruined for you. Like I have a cousin who's super excited. She got a scholarship to a U.S. school for rowing, right? And her coach was abusive, and now she doesn't want to, like, her favorite sport has been ruined for her, right? So be careful, especially for grad school, who you choose as your supervisor, because it is important, actually, right? You want it to be a really formative and generative experience and open up the range of possibles, not to be someone who, is, causes you to burn out, right? Because that's not fun and completely unnecessary, right? Completely unnecessary. So in sum, be technically excellent, follow what you love, and if you want, if you're interested in research, and you don't have to do grad studies if you want to do research, okay? You don't. Like I have been on a lot of master's committees, especially for the nanotech institute. What do students do? They come into a master's research in 18 months, they get a patent, then they'll do their own startup. Okay. So lickety split, they're in, they're out, right? Or you can do a course-based master's, right? So you take, 1 year of courses, and then you have to do a capstone that takes about 4 to 6 weeks. And and then you've got a master's and it takes you under a year. Okay, so that's fun. You can do that too. And then that way you're not doing research. You're like, I don't want to be a professor. You don't have to be a professor, but that's a really great way of demonstrating or getting expertise, technical expertise in a specific area in a very quick time period, right? Sometimes course-based masters are paid, but they tend to be not paid. If you work for an employer, you can sometimes get the employer to pay for your masters. So there's different ways that you can get it done, right? But consider grad school if you're really interested in being like a technical expert in a specific area. But you don't have to be, right? But you can, right? That's always a possibility, right?
Yes. But that's all I had for today. Thank you so much, Professor, for your time.
Yeah, thank you. Thanks for having me. And yeah, I'll have to listen to more of your